Okay, so here's another integral where we're going to need to kind of consider trig identities. So we've got the integral of 1 over cosine squared 2x dx. So we don't have a formula for this necessarily. So we come to think, well, are we going to use cosine? Well, no, we need a sine. Can we use cosine squared? No, then we need a cosine and a sine for our du. So we're kind of stuck in terms of what to choose here. So anytime you kind of feel a little bit trapped when you're doing an integral that involves trig functions, it's worth kind of going through the identities in your head to see, well, could I redefine this function using trig identities and turn it into something that I can integrate, or I could possibly use with use substitution, kind of like we saw with the tangent function up here. So the 1 over cosine might make you start thinking about the secant function like we did. So that ends up being the way to solve this one, is that we say, well, 1 over cosine squared 2x can be written as secant squared 2x dx. Now, integrating the secant squared is something that we can do because we know that the derivative of tangent is secant squared, so the antiderivative of secant squared is going to be tangent. But we have this little 2x here, and this is where u substitution kind of comes in. So this is a baby u sub, I would say, is that this 2x becomes our u, which means our du is just going to be 2 dx, or 1/2 du is equal to dx. And now we're ready to do a u sub. So we've got 1/2 times the integral of secant squared u du, and we know that that is going to give us 1/2 times the tangent of u plus c. And then we just do our substitution or a back substitution, and we have the tangent of 2x plus c. Now it turns out that, with these nice simple linear arguments within trig functions, it's just a matter of multiplying by 1 over that coefficient. So if you wanted to commit another formula to memory, which you don't necessarily need to, but it might be worth noting that in general, we could say that the integral of secant squared of some constant times x dx is going to always be 1 over that constant times the tangent of k times x plus c. We have similar special case formulas for the antiderivatives of sine kx, cosine kx on your formula sheet that I gave you at the start of class. This just sort of follows suit.